Chiong, as we handed over the project from Chiong Brothers, our first task given to us was to find out whether any of the three variables will be able to help us to forecast the average hotel room rate. So with the three variables and going through the deseasonalization mentioned earlier on, we actually went through the methodology that was covered in the findings from our lead review. And we started off with a linear regression. A linear regression that we did was to find out whether the available room nights variable will be able to help us to forecast the average room rate. Well, we used the data from January 2005 to December 2009, which was money data, to construct our model. In the end, it actually returned a p-value of 0.4, which was quite large, and we decided to reject the model as we deemed it to be statistically insignificant. As we do the same thing for the second variable, average occupancy rate, it also returns a very large p-value, which is greater than 0.05, hence we also rejected the model. But the interesting thing to note is that once we move on to the third variable, which is number of tourist arrival, we discovered that the p-value return was actually close to 0. This actually enabled us to deem that the model is statistically significant, and hence we actually decided to move further into analyzing this model. Well, if you look at it, actually the R square and the adjusted R square return was around 0.4, which seemed to be reasonably alright. And so with this model, we actually went on to test it. We used data from January 2010 to December 2010 for our first test, and as a safeguard, we actually have a second test, which was data from January 2011 to June 2012. Well, with that, we discovered that the MAP returned for the first and second test was around 22% to 38%. And so we actually reported our findings with Chiong Brothers. But thereafter, it was actually discovered that our discussion revolved around whether could it be that two or more variables be able to help us forecast the average hotel room rate together. So with the same variables given, we went on to do a mix and match of the variables, and as we carry on with the regression process, we realized that the adjusted R square for three variables is interestingly large, and it's only this model that proves to be statistically significant. So we compared this model to the previous model that we have. So we compared this model, and so we went on to went deeper into our analysis into this model by checking the multicollinearity in this model. Right, they returned a value of 1.3, which shows that it is actually quite a stable model, which has no multicollinearity present. And it actually returned an MAP of around 12% compared to the previous one that we had. And so we conclude that thus far this model that we have is the best that we have. Well, we thought that our job would have finished by now. But the interesting thing is that Chiong Brothers actually told us that International Enterprise Singapore actually has done the exact same study before. But what they did was that they actually used variables like the number of tourist arrival and inflation rate to forecast their model. But because IE Singapore could not share their findings with Chiong Brothers wanted us to find out whether our model, whether these two variables will be able to be a better model for us to predict average hotel room rate. So we did the same model construction for the same period, and then we did the same testing as well. But the MAP returns thereafter was 10% for the first model and around 25% for the second model, which proves to be much larger. Where the interesting thing to note is that the second testing proves to be much larger than our first test. So this left us to question ourselves whether there is any better forecasting model that we can use to better forecast MAPE. With that, I'd like to pass on to Charles, who will touch on the next part.